Yeah. All right, I think we're live. Hello, everyone. I'd like to welcome you to the CAD and Digital Manufacturing Specialization Course Q&A session from Autodesk. If you're new to these topics, CAD stands for Computer-Aided Design, and digital manufacturing is the use of computer-based systems to aid in the manufacturing process. The future of manufacturing sees these roles blend more and more together each year, allowing designers, engineers, and manufacturers to make the use of the technology that's available. These tools include simulation, CAM and CNC toolpath programming, and so much more. So once again, thanks for joining us today. My name is Matt Perez, and I'm the instructor of the Autodesk CAD and Digital Manufacturing Specialization. It's a 5-part course series that we're talking about today. Me personally, I'm a jack of all trades with a background in mechanical design, consumer products, transportation, and really anything else that comes across my desk, in addition to managing a small group of engineers. I also want to introduce everyone to DElia, who's joining us today for the interview and Q&A session. Eli is an industrial designer, drone expert, and co-founder of the Aerial Sports League. If you're into drones at all, you've likely seen some of his amazing work. Given his industry experience, Eli has been the course reviewer for this specialization.
Hi, everybody. Welcome to the show. Good to see you again, Matt.
Yeah, you too, Eli. I also want to note to please leave your questions in the comments below and we'll answer them during the session. So again, thanks for joining us today. The manufacturing industry is making a digital transformation. This transformation is allowing companies to customize production through advances in machine learning, sustainable design, generative design, and collaboration with integrated design and manufacturing processes. Now, I know that's a mouthful, but today we're going to hear more about how generative design is being leveraged to advance the design, performance, and functionality of drones. I want to talk about the topic of generative design so we can understand it a bit. There are many ways to talk about the topic, but the overall goal with generative design is to mimic an evolutionary approach to design. In our case, we're doing this manually by laying out the needs of a design and connecting the pieces of the puzzle as organically as possible. And through this specialization, we only approach this minimally, and this was in the area above our component tray, just because of the modeling time that was required. But the application and the end results are really basically can be displayed across the future of any of the products that you wanted to design. So again, I want to officially welcome Eli to tell us more about his creative process and how he sees generative design in the future of drones and design in general. So Eli, thanks again for joining us today and being the technical expert on the CAD and digital manufacturing course.
Sure.
I want to kick this off by asking you a few questions before we open up the floor to Q&A.
Okay.
So in terms of design challenges and practical modeling, is there anything that you see as drone specific, or do you think that skills used to model and design the drones can really be applied across the board?
Well, you have to have a careful eye to the center of gravity and weight restrictions, the power to weight ratios as a whole. In all things aviation, weight is really king, so you have to really pay attention to that. But aside from that, the class that you put together really illustrated steps and procedures that gave the students a strong foundation and how to use Fusion pretty much across the board universally. I'm really excited with the tools that generative design offers, and I think it's a revolution that's about to happen.
Yeah, I feel the same as well. Thank you. So what do you like specifically about drone design and or design in general that makes you passionate about it?
Well, I'm a little crazy about robots as a whole. I think that's an exciting and we're just touching pretty much the dawn of the robotic era. Aviation, I'm very passionate about aviation. I think drones is a fantastic research and development platform, kind of a robotic canvas to try a variety of ideas and see what works and quickly delete what doesn't work. The technology we develop with drones will extend into all manner of aerospace tech, pretty much. It's really kind of taking over. Drones are taking over aviation in a very big way right now and making things that were completely in the realm of science fiction absolutely possible.
Yeah, it's really cool also that the technology is at the fingertips of everybody as well as where other technology isn't quite there yet.
Oh, the door to entry is really open wide, and it doesn't take much to get involved.
Yeah. So I want to talk a little bit about manufacturing techniques since we focused on 3D printing in this course, but also talked about some CNC machining and like wire EDM stuff. But specifically with your past experience, what are some of the manufacturing techniques that you used earlier on in drone design?
Well, initially, we were using SolidWorks, which quickly moved over to Fusion 360, and Fusion 360 helped us produce our initial drone mold models that we used a CNC router for, and then we were also using laser cutting and thermoforming thermoforming techniques to get the monocoque designs that we were shooting for kind of laid down, and we're able to iterate pretty quickly that way. But as far as 3D printing came along and really changed the game altogether, and it's a perfect match with generative design, because I don't see another way that you can officially tool generative design for the way it works lattice structures, which is fascinating. So I think 3D printing as a whole will be the mainstay for how we do generative design concepts, and how I'm using them in drones now. I've kind of moved away from the traditional plates and carbon fiber standoff approach for generative design, which has gotten me more of a lattice structure for how I'm approaching the airframe now. And I kind of have coined the phrase bird bone approach, because it's a lattice that's almost skeletal, and it's super light and hollow. So I'm getting all the results of like a bird skeleton in my 3D models. It's pretty cool.
Yeah, that's great. It's definitely not a process that you can replicate. Like you said, you can't replicate it anywhere else. And the technology, just like with drones, is, you can get small desktop printers cheaper and cheaper now, where years ago it would have been $5,000, $10,000, $15,000 for $100. You can build some of this technology.
Right.
So yeah, I mean, it's very interesting, because a while back you could build your own vacuum forming setup. You could make your own. You could put plastic in your kitchen oven and melt it and sort of get the tools off the shelf. But even that technology just can't compete.
Right. And I would never don't do that, people.
Yeah, no, that's not the one you want to cook in, for sure.
Right. Yeah. Please don't do that. And currently I have built my own vacuum former to get the size and scope that I'm looking for. So it's really hard to, even these days, kind of find that perfect office 3D vacuum forming system. So, it's still kind of in the realm of DIY as far as vacuum formers go.
Yeah.
Yeah.
So let's shift gears a little bit, and
Sure.
We've touched on manufacturing and how people can get access to these technologies, but let's talk more about the generative approach, because you spoke to it a bit with the bird bone structure, but really, how has that modeling approach changed the way that you think about drone design, or just design in general, when you're starting to lay out a concept or working on design?
Right. So it's not as straightforward as your traditional plate and carbon fiber system goes with standoffs and kind of working from components out. And with my system, it's more of you're building, let's call it a rib cage lattice, right? And so you're building kind of structural facet points along the ribs that you would then put your components onto. And I'm kind of playing with this kind of gyroscopic system now, where I mounted kind of a rotating plate that's always level to the speed of the drone. So the drone will pick up speed and it will pitch forward, but I like my components to remain steady and still and level on the inside, and that way less sensors are doing far less work in fighting the drone itself. Yeah. So it frees up processing power for all these other things that you could be using it for. And drones are basically a sensor package that's in the air or in the water or on the ground. It's really meant as a hauling system for your sensor packages. And what's big right now, of course, are the racing drones are huge, but it's also these selfie cams, the DJI systems and stuff like that, which is cool. That's great. But I also think that's scratching the surface of what these things can really be doing, and we're at the job I'm in right now, we're really kind of pushing it into manned flight. That's very important to us right now. So I think, taking from nature is always what you should try to strive for in all design, I think. And generative design allows us to kind of really play with a skeletal structure that we can then use as a whole new method of mounting internal components on in precisely the areas that we want to get these sensor inputs from. So it's interesting, and it's still very new and very experimental.
It's
I think
very
it's
much
open.
scalable too, though, isn't it?
Absolutely, yeah.
The same drone that you build, like a GoPro or a DJI that has the functionality to track objects and sort of map a 3D environment, or you all perform all these tasks. The size of it doesn't really matter as much as long as the components can be scaled up.
You're kind of starting from a powertrain. The size of your motors and propellers kind of dictate the rest of the drone in a lot of ways. Yeah. So, once you have that established, then you kind of know what size airframe you're going for. So yeah, it is totally scalable, and it's just a matter of kind of having this foundation of what size your propellers and powertrain needs to be, really. Like what size motor are you going to mount? How many motors are you going for? These sorts of things,
Yeah, no, exactly. And I just want to give everybody who's listening, if anybody's just tuning in, so you can kind of get an idea of what we're talking about here.
Right.
We're focusing on a Coursera course provided by Autodesk on specializations for digital design and manufacturing. And specifically, we're talking about drones. The course focused on making a 3D printed drone. But just so you guys aren't wondering what we're chatting about here, that's what we're talking about here today. And I want to move it on just a little bit to talk about just your work in general and areas where, you can maybe inspire the next generation.
Okay, well, you just segued perfectly, because I wanted to say about your course, and looking it over, it was you who inspired me to go down the bird bone path in the first place, with how you introduced me to your method of generative design. So I have to say thank you for that, and it really kind of opened up a whole new level to how I'm playing with Fusion 360 and my approach to drone design as a whole. So we are but standing on the shoulders of greater minds in all things. So thanks, Matt. Thanks for that.
Well, I appreciate that, and if I'm just a small part of some of the cool things that I've seen you create, it's amazing. It's amazing for me to be a part of it in any aspect of it. So that's I appreciate that.
Yeah, and I think you have a very exciting course with your search and rescue drone. I thought that design was exceptional, and it's more of that, man. And I think you're going to do well.
Thank you. I appreciate that. Let's move on a little bit to talk about sort of we've touched on this already a little bit, but let's talk about the future of specifically drones and robotics, because that is obviously the topic at hand, design and manufacturing. But the bigger picture, for you and being a UAV engineer and
right,
just the process of where you think everything is going.
You're asking me where I think it's going, or where I would like to see it go?
We talked a little bit about robotics. Right. And that sort of thing. I just want you to sort of fill in the gaps for the students and get their creative juices going.
Okay, well, first of all, like I said earlier, all of this technology is predominantly off the shelf, and you can find everything from excellent flight controllers that are completely open source, such as the Pixhawk 3D robotic system. But you can also look into and find like the Edison by Intel, or the NVIDIA Jetson system for deep learning and computer vision. And you combine these things, and now you're talking, like the technology that's pretty much what an autonomous car is playing with. And now that we're moving into passenger drones with using this technology and building it up. We'll be making our own proprietary flight controllers that are, being proven through these subsystems. But it's very exciting. But where it's ultimately going, I think, is it's going to sound kind of science fiction what I'm about to say, but I very much believe in it, and it's very much where we're going to take things if we're smart enough. And to put it simply, all the resources we could ever want is right outside our atmosphere, and it just takes harvesting our solar system to put the Earth into a gold rush that'll never end. So how we get there, it's not going to be humans that are on the moon or in the asteroid belt mining away. It's going to be our robotic systems. It's going to be telepresence. It's going to be drone tech. And through drone tech, I think we're going to be able to find minerals and resources we have yet to even imagine, and be able to safely bring it back to our own planet and reap the rewards and benefits of that. And my personal favorite way to kind of visualize this is I see a classroom full of first graders, school kids in the classroom racing away with their little moon buggies from their classroom. Yeah. And they're just having a ball, playing around, kicking up dirt and jumping over chasms and whatnot, whatever you want to do in low gravity. But I would also put a sensor on these little dune buggies that every time they ran over something of interest, it would trigger a mining operation to go and inspect that. And so while the kids are having fun and learning about physics and learning about space, we're also using the same technology as the treasure hunting system to go out there. And a lot of people would say, "Oh, that's kind of that's Star Trek," but I'm going to say no. That's about 15 years, of this type of technology and moving forward. What we're working on right now are literally flying cars and flying taxis, and there's over 50 companies involved in pushing that technology forward. And guess what? We're using drone tech. Yeah. So I don't think it's far-fetched at all to say that our future is incredibly bright so long as we keep going down this path. And I don't fear robotics as a job killer. I actually see it as a means to open up brand new jobs that people have yet to imagine, just like they couldn't imagine what they would do with the internet. Yeah. Same goes for robotics. So I'm personally really excited, and I surround myself with people who are also really excited, and we can only hope to inspire the younger generations to just take this stuff and start making, just go for it. If you've got an idea, the world is hungry for it. So go for it. There should be nothing to stop you.
and sort of to that point, if we go back even just a few years and we look at the technology that was available to, sixth graders,
right? Yeah.
Is what's available now. I mean, the flight controller we used in this course was $10.
Right.
And the functionality built into it is amazing. And even the Pixahawk, I mean, with GPS functionality, you're not breaking $150, right? So,
you're in that ballpark. Yeah.
To get to that technology, even 10 years ago would have been thousands of dollars. And now it's just at the fingerprints with Arduinos and Raspberry Pis and all this tech that kids can just sort of go crazy with and develop and design. So
I would get them involved with Arduino systems as young as possible.
Exactly.
Just understand those microprocessors and what they can do. And they're very powerful, and they're only getting better, and they're only getting cheaper. So it's really a great time to grab some gear off the shelf. Arduino is a fantastic place to start, and just start experimenting with the little robots that you can make at home. And I think it's one of the greatest investments that you can do for yourself. Back in the day, we would go and ask for money for I need a super cell phone and a laptop and an office, and really all you need is an idea and some off-the-shelf technology, and you might be a living and breathing industry in yourself. So, yeah,
exactly. And I also, I know we touched on it a little bit as well, and you mentioned it. The availability of open source technology has also come an amazingly far amount. Back, not too long ago, there was really nothing. Everything was a closely guarded secret. There wasn't much that's open source, but there's been this resurgence of, whether if it's open source 3D printer design or, the technology, the coding or whatever, the Internet of Things, controlling everything through your laptop. It's an amazing time for people to be young and passionate about it.
Right. So I would say in your survival skill toolbox, you absolutely need to know a programming language. Mm-hmm. It's like fire. you need it. So, and if you're going to do anything technological and try to push yourself forward, you need a good programming language. And it doesn't have to be crazy. I mean, Python is easy to learn. Linux is a great system, and that's actually a lot of AI is being developed through Linux systems. NVIDIA's Jetson comes to mind. I'm a big fan of that. And some C+ in there. I know C#. That's kind of what I go to. Yeah. And but yeah, absolutely. Amidst all these microprocessors and this off-the-shelf technology, to weave it all together, you'll need a programming language. But yeah, it's not tough. And the younger you start, the stronger you'll be. So
yeah, you're more able to absorb that technology.
Yeah.
I mean, when I was younger, it was C++ only.
Like it still is. It's good.
Or Q Basic.
Right.
You went into DOS and went
into
Basic.
Well, C++ is a great math language, so you can get your head around that. I think that opens up so many doors for you. So
yeah. And to kind of tie that back into Fusion 360 as well as building APIs to automate some of your design through Python or through C.
Right.
Even a while back, I think there was a JavaScript add-in, but Python is such a universal language across the board these days for so many different things that you want.
Absolutely. But as far as Fusion goes, I don't think you need, I use Fusion every single day to solve a myriad of problems. And I can rely on it. It's incredibly robust, and I have never programmed anything into it, and it's just been able to, I should say I hit, compile a couple of times in order to go out to a CNC machine to write my G code for me. But it doesn't require you to be a programmer or anything, and it's a great place to start iterating ideas. It's super intuitive and very easy to learn. Took me maybe 3 months to really master it and be able to use it for everything. And then, listening to other gurus such as yourself to inspire new techniques and paths that I didn't even consider until, you're like, hey, did you know it could do this? And I'm like, no. So it's important to be a part of a thriving design community too. And Fusion definitely offers that.
Yeah. I know with myself, and I'm the same way. I use it, every day for, again, just a whole host of different things. And
right.
You can get very focused with your workflow and your design, and sometimes you forget to go outside the box and see what's been delivered. And
yeah.
So there's a lot there. It looks like we've got some questions rolling in, so I want to just sort of wrap up our chat and start to get to some of the other questions. But I do want to obviously thank you for reviewing the course and being a part of it.
Oh, it's my pleasure.
It's always a pleasure to talk to you and talk about your designs and everything you do. I feel actually inspires me. Some of the drones that you've designed are, it's so cool, and it's always great to get somebody else's design and perspective and idea.
I want to say though, it's like I don't design in a vacuum. There's plenty of people around me, pointing out good ideas and pushing me to take things further. So it's like I might be the tip of the spear in a lot of things you've seen, but there's always a good team behind me helping me out, and solving problems and stuff like that too. So
yeah, I mean, and actually to that point, I want to make I want to give out a final word, but I also want to get to see if you have anything you want to leave the students with. But to that same point, it's important for especially younger designers. I'm in my late 30s and getting up there, so it's a little bit of a different era than what the students are coming in now. But it's always important to take criticism and take input, right?
And don't take it personal. Right.
You don't ever know the right answer.
Right.
100%. It's always a good idea. Even if you don't use other people's input, always be open and receptive to it, because that's how you grow and that's how you learn. Yeah,
exactly. And never take it personally. Just take it constructively, even if it wasn't delivered with the most tact or diplomacy. Listen to people always. And read between the lines of what people are saying, and it'll just make you a better designer.
So, yeah, exactly. Is there anything else that you want to mention to the students before we start reading some other questions?
Well, my personal philosophy is this, and if you want to predict the future accurately, you need to invent it. So I live by future is by design. So, you know, if you want something that isn't in the world, make it. Just that simple.
Yeah, and it's closer than it ever has been.
Exactly.
You know, financially and just the access to tools, it's there. You can do just about anything.
Yeah, yeah. Anything you put your mind to. So, do we have questions?
Well, let's move on. We've got some questions that have come in, and I think this one actually fits right up right up your alley here. So. Somebody here, Mohammed says, I'm from Maldives and my island is away from the the city with only modern healthcare. And my dream is to live in the island and travel to the city in flying cars. How far am I away from my dream of essentially
2023. I wish I can give you an exact month, but yeah, I can say 2023, 2025. And after that, it's going to just get better and better. So. It's incredible.
Yeah. Mm-hmm. Or design your own, right? I mean,
I'm seeing somebody was flying a bathtub. They found like the motor to weight ratio for a bathtub. So, you know, I would say that you have probably about 5 minutes of flight time and something like that. And I don't know, land in water.
No, but, I remember some of the original sort of build your own sort of science experiments were hovercrafts, right? You get a tarp or a trash bag and a leaf blower and you can hover.
Right.
But yeah, I mean, the technology to design a small one, just start figuring out.
My favorite is that hoverboard that guy's riding across the water. Have you seen that one? He's just like, you know, he's going around like the Green Goblin from Spider-Man. Yeah. I want one so bad. Oh my God, I gotta have that.
Yeah, that's sort of along the similar line of thinking where those the water propelled jetpacks where they hook up to a jet ski and now those things are everywhere, all kinds of resorts and people can go crazy on this.
But to address Mohammed, to give him hopefully a little inspiration, robotic prosthetics that act like limbs are, I think it's already happening, and it's a fantastic era or field of the medical industry to get into, and it's a perfect blend of robotics and the medical field. And I look at people without arms or, you know, missing legs, and I just like, you're upgradable now. You know, you're not handicapped, you're upgradable. Mm-hmm. So, you know, it's think about that.
Yeah, and some of the biotech that's available, not only from, you know, for example, there are plenty of 3D printed materials that are biocompatible now.
Right.
You can 3D print something that could be an implant.
Yeah, But
and
look at what the special effects community has done with puppetry to make a mimic human, human articulation too. So, you know, it's blending the fields. Yeah,
electrical field, and you can basically make fake muscles. You know?
Right. Yeah, and then you make a little microprocessor that remembers these actions, and you know, there's maybe another sensor that knows, oh, I'm near a cup. I have to act like I'm going to reach it out now. You know, reach out and grasp it now. So, yeah, just get creative. Creativity is big.
If you don't have a problem to solve, make one.
Right. And I will say, no, go ahead. Do we answer Mohammed's question? I think.
No, I think so, but I mean, any other information you want to, I mean,
well, I thought I saw a question earlier. It's like, what do you bring to the table if you're a new designer to an employer? And I would say fill your portfolio with two things, and that is try to make realism as much as possible, work on hinges and doors and actuators that can be demonstrated as working, stick to realistic things like, design out a car. Don't get too conceptual. But on the flip side, you also want to show that you're creative, and so you want to kind of show a creative form of problem solving. You know, so like I said, even let's use the robotic prosthetic as an example. Again, you know, you would want to work in a little bit of movie magic puppetry, a system that can remember those actions. And then, you know, it's more of a puppet than it is a robot in a lot of ways. So it's just be creative about your approaches, but try to stay real in your portfolio as much as possible. And I think you'll go far.
I completely agree with everything there. Let's tackle the next question here. Let's see. Is there any? Let's see here. Is there anything that you would change about the drone course for the next revision? All right,
I think that's on you.
Yeah. So along with the drone course, it's always different. Anytime you approach the same problem with a clean slate, you're going to solve it differently. If you do it exactly the same every time, you're not thinking about it enough. So in everything we do, we always strive to make it better. And the same thing with this drone course. Before I ever recorded anything, I had maybe 8 different concepts. I chose the one that was, in this specific case, it had to be the most ideal to teach, right? Not necessarily the best option for the job, but it had to be teachable. So that was one of the things. And even after I made the first version of it and 3D printed it, I changed it for the course to have a removable component tray and just a few things. So if I was going to revise the course, it would be completely different. it would be the same problem, the same design criteria, but the drone would look absolutely nothing like it does now.
I have a challenge for you, and maybe think about a submarine next time.
Mm-hmm.
Like go in a different direction. There's so many people going up. Why not go, under?
Yeah. No, that brings a whole interesting challenge of sealed 3D printed parts.
Right. Yeah. Watertight. Watertight design. Yeah.
And I've done that before. I've had some SLS printed parts that were painted to, completely seal them and cables running in and out of them, and we're submersible for a couple minutes.
That's pretty cool.
But they float. They're hard to sink. No, that's a good idea.
Awesome. I've been wanting to go in that direction myself for a long time. I'm just always taken away from it. Everybody keeps putting, go up. So I'm like, all right, but we're going to space, so I'll make me go down at one point.
To that point, there's so much below us that we don't know about or we haven't explored. I mean, you can even look at some of the the deep wells that have been drilled in the ice caps, and they were expecting to find nothing underneath the ice. And there's all kinds of life forms living there that just they had no idea that they could survive in these conditions, and now we've shined light on it, literally.
Right. I'd love to find the old Spanish wrecks, like a lot of shipwrecks and stuff like that, and just be able to just completely map them and get high-res models out of them, and put the models in museums and leave those things at the bottom of the ocean. I think that's important work. So there's so many things you can be doing.
You can't extract a lot of that stuff, but if you could capture for the masses, or even make a recreation for virtual reality for people to go down and walk through the model and explore it.
Yeah, that's a whole other discussion. Virtual reality. I'm totally excited by that tech. And I think Fusion is also plugging into it too. So I'm looking forward to that when it goes totally online.
Let's see. We got a next question here that we want to attach. How do I upload an image and further model it in Fusion 360 for 3D printing?
That would be through your Canvas, I believe. You want to do that. Look into your Canvas tools. I believe you're asking us, how do you get like something like a photograph into Fusion, and that would be your Canvas tools in the modeling function, I believe. Mm-hmm. And from there, you can calibrate it to the right size, and then you can use your sketch module to start tracing over it and making surfaces from it. And I'm a big fan of T-splines because I can really manipulate T-spline models really, really easily. So you might, rather than using hard surface models, look at explore your Canvas options, your sketch options, and then going into T-splines, I think is a good path.
Yep, I would completely agree with that. I do want to make one addition to that because of the 3D printing comment. With the semi-recent edition of Mesh Workspace, there's so many STL files and OBJ files out there for characters or whatever, and now in Fusion you can take an STL or an OBJ file, which is a mesh file, and work with it. You can't necessarily, it's never a clean transition to go back to what's called a B-rep, or what you would consider a solid body inside of CAD. But you also have the tools where you can take a 3D printed file and sort of manipulate it and work with it as well. So many options. I mean, there's so many different ways that you can do this.
And you'll find your own system after some playing with it. You just like take some of these ideas and ultimately develop your own flow. That's what we all do, so it'll come to you. Like I said, it's practice is what it comes down to. So find the time. Fusion is one of the greatest tools as far as CAD to real world applications that I've ever seen before. You can go from a sketch all the way out to a T-spline model and then send it off to a CNC router or a 3D printer. So your options are vast, and the creative potential is huge. So find your flow.
Let's see here. Next, what are the limitations of Fusion 360? And that's kind of a loaded question.
Right.
What do you think?
I think it's your own imagination. Sorry, because there's always a way. It's there might be another program involved. I have yet to need one, but I always find a workaround. And yes, Fusion's not perfect. There's still programming a lot of the great things that we can do with it. I don't mean to sound like a real evangelist about it, but I do use it every single day to solve a lot of problems. And I always find a way to get the job done, and job done on time too. So its limitations, I think, are really a matter of asking the right people the right questions, and to work around it, and finding a means to get around your obstacles. A lot of people come and they complain, oh, it doesn't do this, and this. And it's like, on the flip side, I've found ways to do a lot of those things. So it's really a matter, I'm sorry, of personal creativity and how bad do you want to get this thing done. And get on the forums, ask people. Everybody has done everything before you. I'm sorry, maybe not in the right combination that you're trying to achieve things, but someone has always walked those steps first. So it's good to seek those people out and find. And also the Facebook Fusion communities, there's several of them. They're fantastic. There's some people doing some really amazing work, and everybody's incredibly helpful. So here's an idea. Pose the question wrong. Know that that you're asking a question, and it's and say that it's right, but it's wrong, and you're going to get 1,000 people going, "Nah, this is how you really do it." And so I find that that's kind of a it's a backhanded means of getting the information you're looking for. So try that out.
One addition I want to make to that, because I actively keep up with 5 or 6 different programs. One thing that Fusion has that nobody has, and I mean, there are a lot of things. I mean, obviously cloud storage is in there, and CAM and simulation and all this other stuff. But the rate at which they update the program and add new functionality is faster than anything I've ever seen. PCB integration with Autodesk Eagle is now in there. So
I know, that's so cool.
And, so going back and forth between a true PCB program, designing printed circuit boards, if you're not familiar with that, and then being able to manipulate the geometry inside of Fusion and go. That functionality, Autodesk and Fusion 360 developers really understand where the software is going. They've given you the free tools, the PCB stuff, the rendering and all that's in there, and it updates at an amazing rate.
And there is a roadmap online, I believe, in the somewhere embedded in the Fusion community. You can look up the roadmap as to where it's going to go too. So it's pretty good. I love that Eagle is now like basically embedded in it, and I think that opens up a whole new realm for electrical engineers to branch themselves over to CAD modeling too. So.
Exactly.
It's exciting stuff.
All right, it looks like we've got 2 more questions that we're going to field here, and then we're going to wrap up.
Okay.
This one, do you have any career advice for someone who wants to enter this field? And I would guess the field is probably drone design, but let's just keep it generic in design in general, whether it's houses, cars, buildings, whatever. Career advice, and you already actually touched on this a little bit, but why don't we expand on it a little bit.
Again, just to bring up what I previously said is fill your portfolio with quality work that can be made. Okay, so if I were to want to take something out of your portfolio and actually make it, please make it so it can actually be done with the machines that we have, the tooling. And I would actually go so far as to show, like, this. Here's my tooling plan strategy in the CAM module for these for my designs. Mm-hmm. I think it's important to show a high degree of realism in your portfolio. But again, you also want to have a couple of pieces that are very fantastic. In the sense that show off your creativity and your interests. And creativity really comes into problem solving. All of us are going to be asked to design. My screen just went black. Here we go. Okay. Mm-hmm. So everybody's going to be asked to hey, make a drone. Well, what do you bring to the table in that? So you have to understand physics. You have to understand your power to weight ratios, your center of gravity, how powerful your motors have to be in order to lift something. Illustrate all that in your designs, and then show your understanding, make an assembly out of it. So when I move an actuator on let's say the hatch of the ship, the whole thing opens properly, and get some creativity going in that respect of how many things can you actuate on your craft, according to that actually work in the real world, and assemblies are fantastic for that too. So
and Fusion has the motion link where you can slide something along an edge and then have something else turn and replicate you can make a controller and then
and that. The first thing that an employer is going to look at is your portfolio. It's really in my field, they look at my portfolio first, and then they look around for a resume and go online and find out who you are. So your portfolio should be very strong. But my point is understand the renderer as well and your rendering options. So get creative about how you show your work. So and you always want them to go, okay, so. Back in the day, I used to work for Phil Tippett, and Phil Tippett told me basically our goal as special effects artists is to make our clients go, wow, and so that has transcended everything I ever do. I always try to get everybody who has to review my work to go, wow, and I think that's very important. So that's understanding the renderer and having some good designs that are toolable. In toolable, I mean you can send them out to a machine and actually have them made. And your creativity all on display as much as possible. So it's I wish I could say it's easy, but it's really there's an art to it.
there's an art and there's time that has to be put in.
Right.
I agree with everything you said, and maybe some of my own personal additions where I've made hundreds of hours of content tutorials, and from cars to obviously drones and many other things in between. And I've seen a lot of people take the content that they've created from tutorials and put it in their portfolio. And to me, that's a big no-no. I would say don't show your employer that you can follow a step-by-step, but take take what you've learned and branch out and make something,
and don't copy.
Yeah.
Don't copy.
Now, if you see a car you like and you want to try to recreate it, that's fine.
Right.
But if you're going to put something in a portfolio, make it unique, show them that you have that thing that they want, that they're looking for.
Right.
And that, I think that realism is a bit lost in this sort of digital age as well. There's obviously with your background, that you can take a rendered image and you can make it look real with enough work, but you don't necessarily need to fake people. But
there's so many different realms, though.
You have to actually make something.
Absolutely, and try to show a model whenever possible. Bring a physical model with you. That's always awesome. But again, there's so many different aspects that we can go in right now. One of the things that Fusion can do is it's an exceptional hard surface modeler for video games. So if you need to make robots I would say, for video games or even movies, if you're going into special effects, Fusion is a great tool to bring with you on that, because it does hard surfaces first. It actually, in my mind, has an issue with organics. And then for that, I would use a whole other program that's more into like clay sculpting, simulated clay sculpting. But as far as hard surfaces go, and like where you would or who you would show what, there's product design, so you have to stay real and show, like the car or something like that. But then there's also video games, which a lot of people are trying to get into, and then you can really kind of like make the crazy robot. But so long as it feels like it's got weight and that it can be a real thing, then you're in the realm of mainstream at that point. So yeah.
Yeah.
I hope that gives you a clue.
No, no, I think that's great. And again, back to some of the original things that we touched on is now with technology, with 3D printers being so readily available, you can actually make and test your designs out to the point where even 10 years ago, you couldn't send something off to be CNC machined unless you wanted to spend hundreds and maybe thousands of dollars to test out a concept.
The other thing I would say is, like, if you have a makerspace, I'm not quite sure where Tech Shop is anymore, but if there's makerspaces in your community, get involved with them. Go to their meetups, get involved with makers in their meetups, and be a part of the community. And it's only going to make you stronger, and it's also going to make you meet more crazy people with big ideas. And you want to surround yourself with crazy people with big ideas. Those are the interesting ones.
The last thing I'll say on that topic, and then we'll move on to the last question, is is to learn from other people, right? You have to make your own mistakes, but along my journey, I've been able to meet some very creative and open people. And that's, I always try to share my knowledge, and I think you do as well, because it's not a secret. You don't need to hold on to it.
Right.
You want to teach everybody else. It's not like you're losing job security or anything.
No.
So find people like in Makerspace or a Facebook forum or whatever,
right,
that you can learn from, people that are in the industry, and then
and that's only going to circle back to your own success, because those guys are going to remember you. Those guys and girls are going to remember what you did for them, and they'll remember, and it'll come back to you in a very positive way. So teach, absolutely. Yeah.
The last question we have here, and maybe we can both answer it. Maybe it might just be me. I'm not sure.
Sure.
What will I get out of taking this course, essentially? So somebody's chiming in that hasn't actually taken the course and just stumbled in. Do you want to field and answer that, or should I just?
I'll keep it simple and say that you're going to learn how to fly, and I think that's pretty awesome.
No, along that lines, and again, this was an interesting course because we tried to keep it as real as possible and actually design and flew the thing that we made. So at the end of the course, you do learn to set up the flight controller and do the test flight and actually go out and see the thing fly. So
and that's very important these days.
Yeah, it's unique because I did spend a little bit of time initially with equations and planning out the power to weight ratio and all that stuff. So if you're interested in learning about drones, there is enough information there to get you started. And if you're just looking for design and don't really care about drones for whatever reason, then that's in there too. You learn to design and you learn to learn the tools.
But also know that drones are kind of the gateway to robotics as a whole. So I would say that learning how to make a drone is learning how to make a robot. Do it so you can understand it, and follow your own path from there.
Exactly. And everything that we did in the course was for a quadcopter, but it applies to a car or a motorcycle or a boat or a submarine or whatever you want to build. You can do it and 3D print it and share it. Share the design and show people what you've done and inspire the next person. Exactly.
I found the course to be quite universal as far as tools and techniques that you would take to pretty much many other designs too. So, the drone aspect of it was really great, and I think people have a lot of fun with it. it's always cool to be able to like put something in the air that you've made yourself that feels so good. And it's a great learning experience to even go deeper. So,
if you do fly it, check your local regulations.
Okay, so to that, there's a website called knowbeforeyouFly.com. You go there, you can see what the rules are for where you live. You put your zip code in, and it'll tell you exactly where you should be flying and what you should be avoiding. And always be a good member of the community. Okay, so if you fly and screw it up, you're ruining it for the rest of us. So please be a good member of the community.
Yeah. All right. So it looks like we're kind of out of time here, a little bit over what we planned on. So I want to thank you, Eli, for joining myself today. And
absolutely my pleasure, man. Thanks for having me.
You're more than welcome. Anytime that we can chat is a great time.
Awesome.
But on a final note on this course and the specializations in general, I just want to mention that we've talked about this throughout our whole session here, but the design in general has never been closer to the masses. With Fusion 360 and its capabilities, with all the manufacturing techniques that you can get access to with maker spaces or tech shops, there's so many facets that you can expand on from here, whether it's industrial design, if you like, making consumer products, or engineering, or if you want to just, do machining, if you want to learn to program CNC machines, the functionality is here. And it has to start somewhere. So on all those different specializations, you need the right tool, and Fusion 360 gives you everything you need there. So I highly suggest, obviously, this course because I made it. So, but it'll give you all the tools, and it'll help you understand and explore the world around you. So, any final last catch line word that you want to say, Eli?
Get out there and make stuff, people.
All right, perfect. Well, thanks everybody for joining. I hope that you got a little bit more information, and again, maybe we'll see you in the next one.
All right. Take care. Thanks, everybody. Bye.
Bye. I think we are no longer live.
Okay.
Yep, we're off live.
It's that awkward, like.
Yep.
Great job, guys.
Thank you
so much.
Thank you.
Yeah, we'll send out the link. There were about, hovering around 90 viewers the entire time, more or less. Like we had 100 and then down to like higher 80s. So it was really great. And then I think the questions were awesome. Both of you were very natural. And Roxanne will send out some more metrics in terms of you and everything later this week. But thank you so much again, and congrats. That went really well.
Excellent.
Great. Awesome.
Thank you. All right.
Take care.
Talk later.
Bye.
Bye-bye. Take care, man.
All right. Talk to you soon.